long division. We set up long division like this. 2748 divided by 13. And the idea of long division is you're looking at starting from left to right with our number that's in 2748. Can 13 divide 2 nicely? No. But if we go over 2 digits to 27, can 13 divide 27 nicely? Yes, it can. So what we do is we write a 2. We write a 2 over the hundred space of the 2700, because really what we're looking at when we look at the 13 and the 27 is, can 13 divide 2700? And the answer is yes, it's by 2, and 200 times 13 would be 2600. But when we do long division, we kind of take some shortcuts. We don't write 2600. We could, because that 2 is in the hundredths spot, and that's really what we're doing, is 200 times 13 and saying 2600. And then we always subtract. If I subtract this, I'm going to be left with 148. What you're basically saying is 200 isn't enough. We still have 148 left. Now we look at the 148. Can 13 divide 1? No. But if we look at the first two numbers here, how many 13s are there in 14? 1. So basically what this 1 is, and you're going to write it over the 10 spot now, it's 10 times 13, which is 130. Now, some people don't write the zeros, and that's fine. But that's basically what's happening. Now, 10 times 13, when you subtract that, you're still left with 18. Can 13 divide 18? Yes, there would be 1 in there. 1 times 13 is 13. Subtract that, and you get 5. Now, 13 doesn't divide by 5, so this one means we have a remainder of 5. So the process of long division is looking at your number and from left to right going until you can divide something, putting that in. So here with the 27, I went up to the hundreds unit place, and that's why I put my 2 above the hundreds unit place. Now with our second one, 4212 divided by 27. Well, 27 doesn't go into 4, but if I go to 42, there'd be room for 127. Put a 27 under there and subtract. Again, you could write these zeros in, because it's really 100 times 27. When we subtract, we're going to get 142 minus 27 is 15. Now, when we go to our next number, 27 doesn't divide 1, it doesn't divide 5. We have to go all the way to 151 and say, how many 27s are there in 151? If there's 5 of them, 5 times 27 is 135. Really, that's 50, so. And when we subtract, we're going to get 2. 1 minus 5 will give us 6. 1. And now how many 27s are there in 162? It works out perfectly. And this one divides perfectly because we see that there's no remainder. So the process of long division is looking at your first numbers until something divides out nicely, and then getting that answer. So I'm going to give you one more now that you've seen some. Ooh, I like this one. Ooh. Can I change one number? Have you done too much? I want to make it more interesting. I want to make this more interesting. There we go. Just to add a little bit of challenge to this one. How many 7s into 35? There would be 5. That would make 35. When you subtract, you'd just be left with 247. There's no 7s in 2, but there's a 7 in 24. How many? 3. Where would that 3 go? That would go right here. Okay? There's a space missing. There's going to be a 0 in there. That's why I thought this one would be interesting. Anyways, 3 times 7 is 21. Subtract and you get 37, and then another 5, 35. So a remainder of 2. Now we're going to do the same thing with algebra. So here's a couple of examples. We're going to look at the first one. We want to divide 3x squared minus 4x plus 5 divided by x minus 2. So we set things up the same way, and we have a similar kind of idea for solving this. Basically, what we're going to look for is if I look at my first term, which is the 3x squared, could I multiply x minus 2 by something to get a 3x squared? And it doesn't matter if you get more than 3x squared, but could you multiply x minus 2 by something so that one of the terms is a 3x squared? You'd have to multiply by a 3x. So what we'll do is we'll write 3x above your x column, sort of the same way that we were managing our units columns with numbers. We're going to manage our algebra columns by like terms. And if you multiplied 3x times x minus 2, you would get 3x squared, and 3x times a minus 2 is minus 6x. After we got our number underneath when we had regular numbers, what did we do next? We subtracted. So we're going to do the same thing here. But you might need brackets here to remember that you're subtracting all of this. The goal is always to have your first one disappear. Did it work? 3x squared minus x squared? Sure enough, that's nothing. Negative 4x minus a negative 6x will be plus 2x, and this one minus nothing will still have a plus 5 at the end. So now we look at our first term. Maybe I'll always under dot line the first term in purple. Under dot line, I like that. So if you have a 2x, is there something you could multiply x minus 2 by to get a 2x? 2. So that's a constant, so we'll put that plus 2 above our 5. 2 times x is 2x. 2 times negative 2 is negative 4. You're going to have to remember, put brackets around it because you need to subtract. 2x minus 2x, sure enough, we got that to be 0. 5 minus a negative 4 will be plus 9. That's going to be our remainder. Maybe I'll do the next one on a whole new page. So here's our next one. If we set this one up, x plus 1 here, 2x cubed minus x squared minus 2x plus 1, and we're dividing, is there something, what was the word I used? I'm going to under dot line, yeah. Under dot line the first one. 2x cubed. Is there something that we could multiply by to get a 2x cubed? A 2x squared. So we'd write that above our x squared column. 2x squared times x plus 1 will be 2x cubed, perfect, plus 2x squared, and then we subtract. Well, this will be 0, which is what we wanted. A negative minus 2 will be minus 3x squared. And then these ones have nothing to subtract, so 1 minus 0 will be 1. I mean, you could put zeros in here and here, but for the most part, we'll just leave it blank. Now we can under dot line, yeah, our first term. And now ask ourselves, is there something we can multiply x plus 1 by to get negative 3x squared? Yes, we'd have to multiply by a negative 3x. That's going to go above our x column. Negative 3x times x is negative 3x squared. Negative 3x times a positive 1 is negative 3x. Put brackets around and subtract. Sure enough, that'll be 0. Negative 2x minus a negative 3x plus x, and then we still have the plus 1. Under dot line, our x, what would we have to multiply our x by to get x? 1 plus 1. When I multiply that, I get x. I get plus 1. When I subtract, there's nothing left. This one has no remainder, which is fascinating because you have started to factor 2x cubed minus x squared minus 2x plus 1. That's one of the things that we're going to be leaning towards in this unit. You've been able to factor quadratics. We're now going to be factoring bigger things. So if I wanted to write a statement, okay, now just getting back to regular math, because sometimes you go into algebra and your whole brain goes poof, right? Let's go back to regular math and think about what does it mean when we divide. If I took something like 56 and I divided by 7, I would get 8, with no remainder. What does that mean? That means that 56 is equal to 7 times 8. That's what dividing means, right? You can rewrite it as multiplication. So we could rewrite our statement right here. We just divided. We divided 2x cubed minus x squared minus 2x plus 1 by x plus 1, and we got that as an answer. So I can write this as an equation, as a statement. I can write it either as a division statement, because this one right here I could also write as 56 divided by 7 is equal to 8, right? So if I wrote ours as a division statement, I would be able to say that 2x cubed minus x squared minus 2x plus 1 divided by x plus 1 is equal to 2x squared minus 3x plus 1. That's what it would be as a division statement. If I wanted to write this as a multiplication statement, and this is where things get really powerful, it means that it's equal to x plus 1 times by 2x squared minus 3x plus 1. Why is this so powerful? Because later on, you're going to be getting questions that say, factor this. And we already factored it once. In fact, if you wanted to, you could now use your previous skills and say, can I factor this? Well, it would have to be 2x and x, 1 and 1, minus and minus. Sure enough, we factored that expression completely. And then if you're able to factor this completely, then you'd be able to find out when it's equal to 0. So you could solve questions like that. And if you can solve questions like that, all of those solutions, as far as their graphs are, those are all x-intercepts. So this is where we're going with this unit. We're going to be factoring things we haven't factored before. We're going to learn techniques to figure out how can I best factor this so that I can divide and see if it works out with no remainder. Then how can I use that to help me graph? And we'll be graphing functions like 2x cubed minus x squared minus 2x plus 1. And when we factor it, we find the solutions when it's equal to 0. Like if I make this equal to 0, can you see that you'll get x minus 1, x equals a half, and x equals positive 1. Those are the solutions when it's equal to 0. On a graph, what does that mean? That means we have an x-intercept at minus 1. We have an x-intercept at positive 1 and 1 at a half. And later on, we'll be able to say, I know that this graph looks like this. Graph things we haven't graphed before. So that's a preview of what's all happening. It starts with long division. It starts with a method to be able to divide a polynomial by another polynomial.